Hey guys, Miss Zubin here, and today we're going to be talking about perfect squares versus non-perfect squares. So before we start actually talking about this new vocabulary, let's talk about what a square is. So let's think, how would you define a square? Try to be very specific. Let's see if you have a good definition. How would you define a square? First thing that you might say is that it is a shape with 4 sides and 4 angles. That does describe a square, however, you need to be careful. There are a lot of shapes with 4 sides and 4 angles that are not squares. Can you think of any shapes that have 4 sides and 4 angles that are not squares? Well, we have the square, but we also have the rectangle, a kite, so there's 4 sides, 4 angles, a parallelogram, 4 sides and 4 angles, and trapezoid has 4 sides and 4 angles. Any shape with 4 sides is called a quadrilateral. So we need to be a little bit more specific when we're talking about squares. How can we be more specific to mean just a square? So let's decide, how can we define a square? So a shape with 4 angles wasn't good enough. So instead, let's change that to a shape with 4 right angles. Now on our square, I'm just going to write on here, a right angle, you probably remember drawing these little boxes. A right angle is a 90-degree angle, and it's the same as the corner of your desk, the same as the corner of a room, the same as the corner of a piece of paper. It's a perfect angle, it's a right angle. This is important in math because this is the middle of being an acute angle and an obtuse angle. It's one of our strongest angles we can use when we're building something. Now let's look at our other ones. Our rectangle, there's a right angle, a right angle, a right angle, right angle. So rectangle has 4 right angles as well. Parallelogram, that's not a right angle, not a right angle. So far we've gotten rid of the parallelogram. Trapezoid, not a right angle. Remember, you want to think like the corner of a piece of paper. So trapezoid, we got rid of that, so that's good. On a kite, those are not right angles, so we got rid of the kite. But we still are not being specific enough. 4 right angles can be found on both a square and on a rectangle. So we need to add to our rules of what makes a square. Can you think of a condition we can add that would make it so that we're only talking about squares and not rectangles? We need a shape with 4 equal sides. What that means, let me clear some space for us to think. We want our 4 sides to have the same length. So this side needs to be the same as the length of this side, same as the length of this side, and same as the length of this side. That's true for our square. However, on our rectangle we have 2 short sides and 2 long sides. Now it's not true, we can't use the rectangle anymore. So this is what we want. Here's our definition for what makes a square a square. It's a shape with 4 right angles and a shape with 4 equal sides. Now hopefully you remember this. You may have forgotten when I asked you at the beginning, but hopefully you remember it now that we talked about it. Our vocabulary for today is a perfect square. A perfect square is the product of a number multiplied by itself. Just a reminder, product means the answer when we multiply. So when we multiply a number by itself, we'll find a perfect square. So for example, 3 times itself, 3 times 3, is 9. If I draw this, I get a square where I have 3 as my length and 3 as my width, and that makes it a perfect square with 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. So therefore, 9 is a perfect square. Let me show you another example. Four times itself is 16. So if I draw that out, I have 4 times 4 gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 can be made into a perfect square when we line it up 4 by 4. So therefore, 16 is a perfect square. Now, not all numbers are perfect squares. So let me show you a number that's not a perfect square. A non-example will be 12 is not a perfect square because there are no numbers times itself that equal 12. Now some of you may be thinking, well, 6 plus 6 is 12. Well, don't forget, we're talking about the product. So we want to multiply. 6 times 6 is not 12. We'd have to do 6 times 2. 6 times 2, which this isn't a square, it's a rectangle. So 12 is not a perfect square. We can rearrange our squares though and try to get closer to a square, and we can do 4 times 3, but 4 times 3 still is not a perfect square. That still makes a rectangle. So 12 is not a perfect square. I want you to notice that the ones that I called squares have the same length and the same width on the same square. Meanwhile, down here, we have the same length and same width. Here's our new symbol we're going to be using today. You may have seen this before, but if you haven't, that's okay. If you have, then you're ahead. A square root is what we're going to be using today. When a number is placed under a square root, we need to test if it is a perfect square. So for example, I could throw the number 1 under here, and we would have to test, is there something times itself that equals 1? I could throw any number I could think of under here. I could throw 102 under here, and we could test and see, is there a number times itself that equals 102? And then I'd be able to say if it's a perfect square or not. Let's run a couple tests and see what happens when we do this on our own. So first, let's see if 36 is a perfect square. We know we're looking for a perfect square to see if it has a perfect square because we have this square root symbol. We're trying to find the square root of 36. If we're lucky, it's going to be a perfect square. So what I like to do in my head, and this will get faster with practice, I'm going to go through my perfect squares. 1 times 1 equals 1. We're not at 36 yet, so let's go a little bigger. 2 times 2. 2 times 2 is 4. 4 is still not 36, so we're not there yet. 3 times 3 is 9. Still not big enough. 4 times 4 is 16. Still not big enough. 5 times 5 is 25. 25 is still not 36. Let's try the next one. 6 times 6 equals 36. We've got it. That's our answer. How we're going to show our answer is that we're going to write that the square root of 36 is equal to the number we multiplied by itself. So our answer here, the square root of 36 is 6 because 6 times 6 is 36. The only thing you have to write in your answer is the number 6. Let's do another one. Next test we're going to do is a square root of 24. We want to see, is there a number times itself that equals 24? If we're lucky, it'll be one of our perfect squares. And again, some of you may already know if you know your math facts. If not, you're just going to have to think it through. 1 times 1 is 1, not big enough. 2 times 2 is 4, not big enough. 3 times 3 is 9, still not big enough. 4 times 4 is 16. 16 is still smaller than 24, so let's keep going. 5 times 5 is 25. Uh-oh, we went too big. There was no answer over here that was exactly 24. So for our answer, we'll learn how to estimate these next week. We just didn't get lucky enough to get a perfect square. Turns out the square root of 24 is not a perfect square. So what we have to do is we're going to have to figure out the best answer we can. For right now, I just want you to write your answer is not a perfect square. The square root of 24 is not a perfect square. That's all we care about. If it's a perfect square, I want you to write the answer. And if it's not a perfect square, just write the words, not a perfect square. Let's try another. The square root of 13. So again, we're going to test to see if there's a number times itself that equals 13. Let's check our perfect squares. I'm going to keep multiplying a number times itself until I get either the answer I'm looking for or I've gone too big. 1 times 1, too small, equals 1. 2 times 2 equals 4. 4 is smaller than 13, we can keep going. 3 times 3 is 9. 9 is smaller than 13, let's keep rolling. 4 times 4 is 16. We went right past it. 13 was not one of our answer choices here. So for my answer, I'm just going to write that the square root of 13 is not a perfect square. We'll learn how to estimate this to put an actual answer there next week, but for right now, we're just going to say it's not a whole number. Let's try one more together. The square root of 49. So again, as we do these, you may know right away if this is a perfect square or not. But for right now, let's go through the numbers that we know are perfect squares. 1 times 1 is 1, not big enough. 2 times 2 is 4, not big enough. We want that answer to be bigger than 49, and 4 is smaller, so let's keep going. Well, actually, we want the answer to be exactly 49. That'd be the best case scenario. 3 times 3 is 9. 9 is smaller than 49, so we can keep going. 4 times 4 is 16. Still can go bigger. 5 times 5 is 25. 25 is a perfect square, but it's not big enough. We want 49. 6 times 6 is 36. 36 is still smaller than 49, so let's keep going. 7 times 7 is 49. Well, look at that. We got lucky. 49 is exactly 7 times 7, so that means that the square root of 49 equals 7. If you need to go back to any of the examples, feel free to do so. If not, go ahead and move on.